Okay, so our first washers example is pretty simple, but I think it'll communicate the idea behind what we're doing and hopefully give you a clear sense of what's going on. We are wanting to take the region that's bounded between the square root function. These come up a lot, right? So we've got the square root function looks like this, y equals root x, and the parabola that hasn't been shifted or anything looks like this, so it's a pedal, and the parabola is y equals x squared. We are revolving over the x-axis to obtain a solid. I don't know if I can make this look symmetric or not, but it looks something like that. And so we do have a hole in the middle, which means we're going to need to be using washers. And remember from our last couple of videos, washers are really just the difference between two discs. There's one, I've been using blue for the outer one and yellow for the inner one. And you can see here pretty clearly that the outer radius goes from the x-axis all the way to the square root function. The inner radius goes from the x-axis all the way to the parabola. So volume using washers is going to be pi, remember? Integral from a to b, outer radius squared minus inner radius squared, dx in this case, since we're revolving over the x-axis. We're going to need to figure out what our limits of integration are, and that's when these two functions equal each other. That happens when x is 1. So our volume is going to be pi integral, and you can set the two equations equal to each other to find that out, but integral from 0 to 1, outer radius falls, it's the blue one, falls on the square root function, so we're going to do the square root of x. That's going to get squared, minus inner radius is the parabola. So we've got x squared, and that gets squared. And then we have a dx because we're adding in the horizontal direction. This is just going to be a power rule problem, 0 to 1. We have, this is x minus x to the 4th dx. When we integrate, we have pi times x squared over 2 minus x to the 5 over 5 from 0 to 1. When we put in a 1, we've got pi times 1/2 minus 1/5. And when we put in a 0, we just get a 0. So this is pi times 5/10 minus 2/10, just getting a common denominator, and this is 3 over 10 pi. So pretty straightforward, just important to identify which radius will be the outer radius, which one is the inner radius. And once we have that figured out, it's very much like we work with discs.